Hi everybody, this is Enriched Algebra 2. All right, we are figuring out writing equations from a graph. All right, here we go. Okay, now we've learned how to move things left to right or up or down, flip them sideways, flip them upside down, and stretch them. So this is your parent function, y equals x squared. Notice it's here in the middle. It's not moved up or down or left or right. And parabolas usually go over 1 up 1. This one goes over 1 up 1. So that is your parent function. Okay, the next one. This parabola starts at 0, 0. So we don't have to move it up or down or left or right. Now it doesn't go over 1 up 1. It goes over 1 up 2. So over 1 up 1 was changed to over 1 up 2. So 1 was multiplied by 2 to get it to be a 2. Changing a 1 into a 2 is a vertical stretch. Vertical stretches go in front. So that is our final answer. Okay, let's find some more parabolas. Let's try this one. So this one's a parabola, y equals x squared. You don't need to move it up or down or left or right. Now, over 1 up 1 was changed to over 1 up, well, I'm not quite sure, some weird fraction. So we could either try to figure out the weird fraction, nah, that's a terrible idea, or try going over 2 up 1. So over 1 was changed to over 2 up 1. So to change a 1 into a 2, that would be a horizontal stretch. Horizontal stretches go in the formula under the x, right there. So it's y equals x over 2 squared. So we could have tried to figure out the vertical and had it be a vertical shrink. But instead of dealing with some weird fraction, we just made it into a horizontal stretch instead of a vertical shrink. But either one is theoretically possible. Okay, is that it for parabolas? It looks like it. So let's move on to absolute values. Okay, this is the absolute value graph. Okay, this one has not been moved left or right or up or down. And this one goes over 1 up 1. Absolute value graphs usually go over 1 up 1. So that is our parent function. Okay, now let's try a couple of these others. So this is an absolute value. It's been moved to the right 2. That goes inside the formula, and it's x minus 2. Okay, because minus moves it to the right. Now the last thing I'll check, so first I move it left or right or up or down, then I flip it, and lastly I check the shape, the vertical or horizontal stretches. You can do it in a different order, but this is the order that makes most sense to me. So over 1 up 1 is what an absolute value graph usually does. This one does not go over 1 up 1. It goes over 1 up 3. How do you change into 1 into a 3? You multiply it by 3. And up is a vertical idea. So where does that go? That goes in front of the equation. So you have y equals 3, absolute value of x minus 2. And you're done. Okay, what else do we have for absolute values? We have this one. So this is an absolute value graph. This has been moved to the left 2, down 1. So left 2, that's x plus 2. Down 1, that's a minus 1 after the formula. Now we check the shape. Absolute values usually go over 1 up 1. This one goes over 1 up 1. So we're done. All right. What else do we have here? And why are these in a strange order and not numbered? Interesting. This is a cubic. Cubics usually start at 0, 0 and go over 1, up 1, over 2, up 8. This is our parent function cubic. Nothing has been changed. Okay, this cubic. So this is a cubic. This cubic has been moved to the right 2. To the right, strangely, is minus. Now, this cubic usually goes over 1, up 1. It's been flipped sideways or upside down. Which one? It could be either. Flipping it upside down is easier to write and more common. That negative goes in front. So it's a cubic moved to the right 2 and flipped upside down. Okay, last we have the square root graph. Square root graphs usually start at 0, 0 and go over 1, up 1. This is the parent function square root graph. This one below it is the square root graph. That's been moved to the right 2. Right, weirdly, is minus. Now, square root graphs usually go over 1, up 1. So this one's flipped upside down. So I need a negative in front of the formula. Now, does it go over 1, down 1? No. Over 1, down 1 has been changed to over 1, down 2. To change a 1 into a 2, and it's down, so it's vertical. So you put a 2 in front, and you're done. Last but not least, we have a square root graph that has been moved to the right 1. It's been flipped sideways. Sideways flips go inside the formula. Notice that I had to put the x minus 1 in parentheses. That is a tricky detail, to flip it sideways. Now it goes back 2, up 1. It usually goes back 1, up 1, but then this one's been changed to back 2, up 1. So from back 1 to back 2 is a horizontal stretch by a factor of 2. And horizontal stretches go inside the formula. Make sure your square root is big enough. That whole thing is inside. Notice how the x minus 1 is in parentheses and the square root got bigger. That is a tricky one to write, so pay close attention to that one. It is tricky. Okay, good luck. That's everything. We'll see what happens.